In episode 16 of Mobycast, Jon and Chris discuss how they recently troubleshot a client's distributed systems. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
Welcome, Chris and Rich. It's that time of the week for another Mobycast. I'm excited to talk today.
How's it going?
Hey, Jon. Hey, Rich.
Good. Yeah. So, Rich, what have you been up to this week?
So this week we've been focusing on, there's a transition happening in WordPress. They're moving more towards JavaScript and they're rebuilding their editor in React. It's a project called Gutenberg. And so it's been a project for like almost 2 years now, I think, but only recently has it really started to show how powerful it's going to be. So as a business internally, we've decided to go all in on it. So we're now heavily diving into JavaScript and trying to learn that thoroughly. So we'll be probably focused on that for the rest of the year.
That sounds fun. And what about you, Chris? What have you been up to?
I am busy packing. So I am getting on a plane tomorrow, heading out to San Francisco for DockerCon 2018. So it's going to be fun. Spending 3-4 days out there. All things Docker and containers.
I'm picturing a graph of how much you'll learn each day, and it's a step function as you run out of new learning capacity and get more tired as the days go on.
Yeah, I need to stop by in the store and get a few more RAM chips or something.
Yeah. And as for me, this past weekend was the GoPro games in Vail, and they used to be the Teva games, and it's just amazing to see this event that went from like, oh, let's have some weird sports several years ago to now like 100,000 people and, booths everywhere and GoPro booths, climbing and slacklining and just wall to wall entertainment for people. It's craziness. It's so interesting to see how big that's gotten. And it actually made me think that, it made me have this realization that as we do these trainings for people that we're teaching, containerization and Docker and running on AWS, that maybe we should start offering some of them up here. There's just so many fun things to do up here that I bet we could entice some people to come up to the mountains of Colorado for some of this training.
That's rad. Yeah. I love that. I love the GoPro games. That's probably the piece that I miss most about Vail.
They are so fun. So today we're going to talk about troubleshooting. At Kelsus recently, we've had a couple of things come up that involve our containerized infrastructure. And it wasn't as simple as stepping through code or looking at a stack trace and seeing, oh, this is what's obviously wrong. It involved some peeling back of layers and thinking about the infrastructure. So we thought we'd talk about the thought process that we went through. So maybe we can just start by describing what happened. Tell us what happened. When did it happen? What were people seeing, Chris, when we realized we needed to do some troubleshooting? My hope, before you even answer that question, my hope was that we got a nice alert that told us exactly what the problem was and how to fix it. Is that what happened?
Yeah. I mean, they're
in an ideal world, that's what would have happened.
Sure. No, I mean, the symptom was deploying a new microservice to support a mobile application. And upon deploying that and starting to test it, seeing failures and calls to a dependency, and those failures did show up as alerts coming through the whole system, through the login system, and then being raised as an alert using sumo logic. So we knew immediately when these things were happening. Indeed, the big question was like, okay, what's going on here?
Mm-hmm. So we're getting some alerts, and the service that we put in, it's just not, it's timing out, did you say?
Yes. So the first version of this mobile app was going straight. There was no backing microservice to it. Instead, it was going straight to this other backend dependency controlled by another group, by another team, and for various reasons to kind of add on, additional functionality for this mobile app, better traceability, debugging, troubleshooting, whatnot. There was the need for us to create a microservice, a specific microservice for this mobile app to communicate through which some of these core calls that the existing app was making would be proxied through that microservice. And so that's where we ran into problems, were these calls that were being proxied through our new microservice to the backend dependency, which were the exact same calls that the existing mobile app was making.
All right, so we should probably give some names here. Otherwise, it's going to be hard to talk about the dependency and the microservice. And which one are we talking about here? So let's give everything a name. So we've got a mobile app. That one's easy. Let's just call it the mobile app because there isn't another one. And then we've got a microservice that's sort of the proxy. Should we call it the proxy service? Mm-hmm. And then a backend dependency. Let's just call it the backend service. So we have a mobile app, a proxy service, and a backend service. And you're saying the mobile app is making calls to the proxy service, and the proxy service is in turn making calls to the backend service. Is that right?
Correct.
Okay.
In the existing app, it's the mobile app is making those calls directly to the backend service.
Okay, so before there was no proxy service, and now there is. And the mobile app. So what is aside from these alerts that are saying, "Hey, there's some timeouts"? Is there anything that's happening to users? Are users noticing anything because of these timeouts?
Mm-hmm. So this is a brand new service. It's not yet rolled out to customers. So it's just being tested, right? So it's so the only ones affected are just us doing our own test to make sure that everything is running before we go and deploy this and roll it out to all of our customers.
Okay, got it. And so as we test, what are we seeing? Are we seeing the mobile app sitting there spinning all the time, every time, sometimes? What's happening to us as we test?
Right. Yeah. I think I don't even think we got that far. I think it was just we're using some test tools, and it may very well be scripts or curl making these API calls against the proxy service to do the various bits of functionality that the mobile app needs to do, and then the end result is then seeing these timeouts that are happening, in the backend app.
You just mentioned curl, and you reminded me of a conversation that we had when this was going on, and I think it's worth repeating what you told me about how curl ended up being kind of the proof that we needed.
Yeah. So, I mean, that kind of gets into a little bit of like, okay, how do you go and troubleshoot this?
Right.
And I don't know if we want to, maybe we could lead up to that, and get to that, and talk about just like, okay, how do you just go about like, these are the symptoms. We can talk a little bit about like what happened, the path that people went down, and then
got it.
Kind of like, stepping back from that and peeling it back. And really, I think, because really what I want to highlight about this is a super common issue that I see time and time again is that, distributed systems in the cloud, microservices, containers, networking issues, like these are very complicated systems. And you can't Google your way to an answer. You can't Stack Overflow your way to an answer. You really have to have a good understanding of all the different parts in your system, what's communicating with what, all the various paths where failures can happen, to be able to troubleshoot this. And so time and time again, I see people just kind of getting stuck immediately out of the gate and kind of just making guesses about what's wrong, and then going and just throwing things against the wall and seeing what sticks.
I just wanted to add in, I guess the reason that I was going down the road of, why did we use curl was because the thing that I want to point out, the thing that makes this even more classic and even more like, as you say, a common type of problem that people have to deal with is that there were two teams involved. And so whenever there's two teams involved, you do get a little bit of human troubleshooting as well, like pointing fingers. Oh, no, it's on your side. No, it's on your side. So that was kind of what I was getting to.
Yeah.
So, okay. So now that we've sort of revealed that there are, teams that maybe don't see eye to eye about where the problem might be, now we can kind of continue down the road of, okay, so what did we do? What happened? Who did what?
Right. Yeah. And so, I mean, where we're at is, so we know that we have this existing client that's making these backend calls. We're not seeing anywhere near the kind of error rate with that, right? So like things are really kind of working. This has been out there in live production now for many, many months, and it's working very, very well, right? We're not seeing these kinds of error rates. we then deploy this new proxy service to be a middleman between the mobile app and the backend service. And right out of the gate, just in very limited testing, we're seeing high error rates, like on the order of, kind of feels like 50%. It's probably not that high, but it's definitely a very high percentage of calls are now timing out. And the head scratcher here is that it's making the same calls, right? Like that the existing mobile app is doing that. The existing mobile app is not having issues with, but our proxy service is, right? So that's where kind of like where we, the existing, like the problem where we start off with the initial state. And so what kind of happened was just so we reported the timeouts to the other team. Kind of like the consensus was among kind of everyone was like, oh, timeouts. That means that you don't have enough computing power, right? So there is a backing database for that backend service, and so people were thinking, oh, we just need to go increase the size of that database instance, right? And therefore, we won't have these timeouts. And that's kind of the route that people started going down, and quite a few people looking into that and trying to look at database performance and seeing if there were queries that could be optimized or indexes or how to move to a bigger instance. What are the repercussions of that? And I was kind of watching from the sidelines and saw that. And that's when I started asking some questions. Because, it doesn't feel like that this is, even though sometimes, timeouts are indicate that, hey, something is overwhelmed. It's not necessarily, that's not the only reason why you would get timeout. And the thing that stuck out to me was, you have this existing mobile app that is making the calls straight to the back end service, and it's not seeing these timeouts. We're only seeing the timeouts through the proxy service.
Which is such a weird thing, right? Because as soon as you say that, it's like, oh, must be a problem in the proxy service.
Exactly. Yeah,
that's the thing that changed. So it must be at fault.
Right. Yeah, and so you start asking yourself, okay, what are the dependencies here? Like, what are the communication paths? Like, what's talking to what? Right. And then because it leads. There's a lot of things actually where this could be going wrong. So it could be something as silly as the code in the proxy service, the way that it's making HTTP calls to the backend service. Who knows? Maybe it's configured incorrectly and it's set to like a 2-second timeout or something like that. Let's just say, right? And so it could be timing out prematurely. I don't think at that point that we even knew exactly like how long these timeouts were, right? Like, was it 60 seconds before it timed out, or was it kind of like an immediate timeout, or was it somewhere in between? I'm not sure we actually had that data, but that's one place where it could be going wrong. And
let me just pause for a second here, because this is, both Chris and I are familiar with this problem and what happened, but I just want to make sure that we're explaining it in an understandable way. Rich, are you following this? You kind of see? Can you picture the architecture in your mind? A mobile app calling a proxy service that calls the backend service.
Yeah, I'm following right along.
Okay, great. Okay, sorry to interrupt, Chris. Let's continue.
Yeah, so one place where it could be is it's actually in that code for the proxy service, whether it's a misconfiguration on how it's making its HTTP calls to make these API requests to the backend service. It could be who knows? It could be a permission problem, a security issue. It could also be, this gets more into like cloud specific and architecture and networking, but each one of these services is always fronted by an ELB. And ELBs themselves, the way you have to kind of think of it is, they're basically a computer themselves, right? Like 99.999% sure that ELBs and Amazon are software load balancers, not hardware devices. Think of them as
by the way, ELB is an elastic load balancer, right?
Correct. So you have these. You can think of it as it's definitely another hop, right? And it's another thing with software in it that's making decisions and whatnot. So ELBs and Amazon, they all have timeout logic of their own. So, and these are settings on the ELBs themselves. By default, they're set to 60-second timeouts. So means for incoming requests that come in. And so maybe to back up just real quick, like I said, ELBs, Elastic Load Balancer, really what they are is they are a way of turning a collection of stateless services into a cluster that can be, that you can basically round robin through. So it gives you both scalability and availability advantages. So, you might have an ELB with like 3 instances of your service behind it. And then this way you have 3 times the throughput. And then also, like if one of those services dies for some reason, you still have 2 that are up and running and can still answer that question. So these ELBs, they get these incoming requests to say, I want to access one of those things. I need this capability, this service call. The ELB will then route it to one of those instances. And then when the instance responds, it then proxies it back to the original caller. All that said, the ELB, like if the request takes longer than the timeout period, it will actually terminate the connection and return back a 503 error code to the caller, which is kind of interesting because it could be that the backend, that whatever service is behind that load balancer, it may still be crunching away and working on it. And, right. Maybe it takes 70 seconds for it to complete. And as far as it's concerned, everything is just fine. It just, what happens, it doesn't realize that the ELB gave up on it and terminated the connection. So when that service behind it finishes and sends the request, it's going out to, basically dev null,
right.
Because the client got disconnected. So that's something else to consider in this whole puzzle is, is it an ELB timeout or is it a timeout actually in the service itself?
Hey, this is Rich. You might recognize me as the guy who introduces the show, but is pretty much silent during the meat of the podcast. The truth is, these topics are oftentimes incredibly complex, and I'm just too inexperienced to provide much value. What you might not know is that Jon and Chris created the training product to help developers of all skill sets get caught up to speed on AWS and Docker. If you're like me and feel underwater in these conversations, head on over to prodockertraining.com and get on the mailing list for the inaugural course. Okay, let's dive back in.
One thing I just want to make sure we're using the right terminology. On ECS, is it ELBs or is it application load balancers, ALBs?
An ALB is a type of ELB.
Okay. All
right, so the ELBs come in 3 flavors. So you have your application load balancers, which are path-based routing, and they work at layer 7. Then basically they only would do HTTP and HTTPS.
Okay.
So they're working at the application level. That's why they're called an application load balancer. You have the classic load balancers. Those work at the network level, layer 4. And so those can then work across, all the different protocols, whether you want to do TLS or if you want to do SMTP or POP3 or whatever internet protocol you want. It's working at that networking level. And then they have another one called a network load balancer. And that one is at an even lower level of network. It's basically like more like the pure metal version of it. So three different types of flavors of load balancers. And with ECS, some of our services may very well use classic. We prefer the ALB because usually there are advantages to the ALB. There you can actually front multiple microservices with a single ALB if you kind of design your routes correctly.
Right. Okay. Sorry. So I was thinking about that exact thing, which is why I thought, oh wait, it's ALBs. Anyway, so you've just discussed here's what our load balancers are doing, and so to kind of go back to the problem, we just need to get some proof around what's happening because still the service is working unless you call it through the proxy. So what happened next then?
Right. So so then so the suggestion is like, okay, well let's see if we can kind of like isolate part of this. So like, what if we just do a curl against the actual backend service itself, and can we actually see these timeouts happening? Are they happening that way, right? So that way you're removing the proxy service from it. You're removing the ELB of the proxy service from the equation, and you're now going back to that, that's straight back to the backing service. So as a first step, let's go see what that gives us, right? And so in doing that test, what happened was one of the people on the team, when they did that, they saw that, sure enough, one of those calls timed out after about 60 seconds, but then they did it again and it came back with a successful response in 3 seconds, right? So like radically different, experience. And this is kind of keeps happening. Like sometimes it takes, really long, it times out, and other times it's kind of like normal and it just responds. So that's kind of what we had next. And so like the team was kind of like, well, look, see, it's proof. Like it's the other team's problem, right? They are timing out, right?
Right.
It's like,
it's not the proxy service's fault, because curl going directly to the backend service still shows the timeout.
Mm-hmm. Indeed. So then it's like, well, let's dig a little deeper here and see like what's going on, because the thing that sticks out there is this wide discrepancy, right? So you have, sometimes it takes 60 seconds and sometimes it takes 3 seconds, and it's really it's not like it's like the 60-second calls are all happening in a 1 hour window during peak hours, right? It's like these are back-to-back calls, right? Mm-hmm. So that's really, so in a way it was super good news, right? Because it's like, okay, this right here, this smells like we have probably some sick server, some degraded server that is in that cluster behind the ELB, right? That's not working correctly. And so what's happening is, for those requests that time out, they get routed to this sick thing, and this whatever. Maybe it's really slow. It doesn't have enough memory. Maybe it's having problems with disk space. It's swapping. Whatever, something's going on. So, and so that kind of makes sense, right? That matches up with kind of like the behavior that we're seeing. And so the next step is you can just enable verbose mode on curl, right? To see exactly the steps that are happening when curl is trying to make that request. Mm-hmm. And that's when things got even more interesting. So when we turned on verbose mode for curl and make these requests, what was happening is on the ones that were timing out, it was making, when it first did its initial attempt at this, it was basically, it was looking up the DNS record, right? The DNS record for this is actually round robin DNS. So the DNS entry, because this is a load balancer, and because the load balancer was defined to be in 3 AZs, that means there's 3 separate actual load balancers, and they all resolve to the same DNS name. So just call it like elb.amazon.com is the DNS name. And in that, there's 3 IP addresses for the DNS record. So curl, what it does is it says, okay, you want to make a connection to dns.amazon.com or elb.amazon.com. And when it does that, it looks up the DNS record. It sees there's 3 things, and it's up to the client implementation what they want to do. So, really clients should do something like round robin, or whatnot, but they don't have to. So it's just, they can pick one of those three addresses and go ahead and make a connection to that IP address. And so what we're seeing is that when, out of these 3 IP addresses, one of them, when the client first picked that one, that was the one that was not responding. And so in curl, what was happening is I think curl had a timeout of about 15 seconds. And so we'd see this wait. It's like, you can see it resolved in verbose mode. You can see it did the DNS resolution. It resolved it to the IP. It tries to make a connection to the IP, and it's just hanging there for 15 seconds. It then times out, gives up, and then it goes back to the DNS record and says, I'm going to try another one. And so it grabs another one. And when it grabbed the other one, then it connected just fine. Right. And so this happened multiple times. And every time that it failed, it was that one IP address out of the 3 that it was trying to connect to that just wasn't responding. Right. So this was really, really, interesting and good information to have, because now we knew that it looks like the problem is it's the problem with the ELB. It's not with, the backing service or anything like that. It's the actual ELB that's having a problem. Mm-hmm. And so when when we figured that out, that light bulb goes off where it's like, okay, why would an ELB go bad? Like, why would it have problems? And chances are, you can't reboot an ELB, right? Like, it's a managed service. Amazon controls that, so the likelihood that like it's overwhelmed or it's out of whatever, right? Like that's probably not the cause. So instead, it's probably something related to networking and security and permissions and whatnot. So with that, then can go into Amazon, into the console for the ELB, look up that ELB and see how it's configured. And when we did that, we saw that it was correctly using the 3 availability zones. But what happened was the subnet definitions that it was using turned out the one ELB that was not responding back to request, it was on a subnet that did not have an internet gateway. So because of that, it was basically hidden from the internet, from internet request. And so that's why it couldn't service these requests, is because basically it was that particular ELB was configured to be a private, on a private subnet. It's a private ELB that's not supposed to connect to the internet. The only way really to connect to that would have been if you were actually inside the AWS data center itself, either through a VPN or on another machine that's actually inside there and using the private IP.
And that's something that I always keep in mind is when networks are unobtainable to the internet, like when you cannot route to a network through the internet, the behavior is typically a timeout as opposed to a refusal or something like that. You usually get that try. Okay, I give up. Even though, and that the network is there and it should be available, but when it times out, that's when you start thinking, is this thing accessible to the internet? Can it be reached?
Mm-hmm. Absolutely, yeah. So, like I said, definitely, for sure, that's like a big, smoking gun, and it's like this is either a routing networking issue or it's a permissions issue that's preventing that from happening, right? Yeah. And so the fix for this was really simple. It was just like, hey, we need to correctly define this ELB to use a subnet to make sure that all the subnets that it's using do actually have internet gateways so they can talk to internet traffic. And so once that incorrect AZ was swapped out, the subnet for that AZ was swapped out to one that was correct, that actually had an internet gateway on it, then lo and behold, everything worked just fine.
So the thing I'm still confused about is why was it that the mobile app before the proxy didn't have the same problem? Mm-hmm. Isn't it hitting the same ELB DNS name?
So that's a great question. And it's because of an architecture decision where there's actually 2 ELBs fronting that backend service. So there's one that fronts it for public calls and one that's for internal only. And so what happened was, because if going against the internal only one, it would have been fine, right? Because that meant that in order to access the internal only one, that whatever was connecting to it was not on the open internet, and it could make that connection versus going through this other. So the part of it was the proxy service was trying to go through the public interface. And that was causing some issues. I think there was also some affinity for how the client was connecting to the public-facing ELB on what ELB it was connecting to as well.
Interesting. Well, I'm glad we didn't just make a bigger database.
Amazon's bummed out, but
So how long did this take for you to figure out?
10, 15 minutes, maybe.
I thought it was a lot longer than that. From the time that like the problem originally surfaced to when it was fixed was probably like 3 days and involved quite a few people. Okay.
And then when I got involved, again, I had the opportunity to kind of look at it with fresh eyes and come at it from a different angle. That's the part that was, it went rather quick then.
Okay, got it. Well, thanks for taking us through that really interesting troubleshooting lesson, really. And we'll get back to each other in a week and talk some more.
Awesome.
All right. See ya.
Great. Thanks, guys. See ya.
Bye.
Bye.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/16. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.